Okay, so we're going to take a look here at problem 6.8, and we're asked to identify whether something is functioning as either we'll call a nucleophile or an electrophile. All right, so in molecule A here, we see that we have what's called an alkyl halide. So we have a carbon that is bonded to a halogen, in this case, bromine. And bromine is electronegative compared to carbon. So this would be slightly negative charge, right? An electron withdrawing group here. And this would create a slightly positive site at the carbon. So this would be considered and an electrophilic center, right? This is a slightly positive area, so it's looking for an electron. So this would be an electrophile, we'll call this for A. Let's look at compound B here. And compound B, our focus should be on this functional group, this alcohol functional group, this OH hydroxyl group. And the lone pairs on the OH group can function as a weak nucleophile. So this would be a nucleophilic site, a nucleophilic center. So this answer would give us a nucleophile. Our next example, we're going to focus our interest on this carbonyl, which has an electron withdrawing group here, this more electronegative oxygen, which would take away the electron density from the carbon. So we'll see this slightly positive center here due to both resonance and induction of the electron withdrawing group. So this would be considered, again, an electrophile. All right, this next example shows a pi bond here. So this pi bond, in general, this could be called an alkene. In this specific case, it's a cyclo or cyclic alkene. And this is an electron-rich pi bond here. So we would call this a nucleophilic center or a nucleophile. Next, we have example E, which has a positive formal charge. This is a carbocation, and this would be considered an electrophile as well, right? It's just, it's very electropositive at this site, very positive formal charge, so it's seeking electrons. Next, in molecule F, we see this negative formal charge on our oxygen here. So that indicates that we'd have 3 lone pairs. And this in general is called an alk oxide ion. So just the fact that we have an alkyl group connected to this electron-rich oxygen, this could be considered a nucleophile. All right, in our next case here, we want to consider the fact that this is an ionic compound, and we have this sodium counter ion on our bromine anion. So the bromine here is electron dense and can serve as a nucleophile. We have a similar case here with a lithium, a positive +1 counter ion, and a hydroxide ion over here. So this oxygen has that negative formal charge on it and 3 lone pairs, and that will be an electron-rich hydroxide anion, which is also a nucleophile. Next, we have an alkyl halide again, right? So this is my alkyl halide. This time we have methyl iodide. So by the same reason as in molecule A, we have this carbon iodine bond here, and this is an electron withdrawing group over here. So this would have a slightly or partial positive charge on our carbon, right, and all of our hydrogens extending from it. But this carbon here would serve as an electrophile because of its partial positive charge. Last but not least, we have this, this molecule is called potassium tert butoxide. So what happens is a potassium ion comes off, and then we have this oxygen, and this is kind of the structure of the tert butoxide portion. And it's an alkoxide again, right? This alkoxide anion results. And because of all these lone pairs on the oxygen, it's electron rich, and this can also serve as a nucleophile. So next time we'll take a look at practice problem 6.9.